All right, looking at section 6.4 and 6.5 in our geometry textbook. A quick little walkthrough here. We talk about properties of special parallelograms. So special parallelograms, so we have a parallelogram, and then there are three, if you look back at your hierarchy, there's three that branch off. We go rectangle, rhombus, and then a square. So one thing to think about is all rectangles are parallelograms, all rhombuses are parallelograms, all squares are parallelograms, all squares are rectangles, all squares are rhombuses. But rectangles are not rhombuses and vice versa, and all rectangles are not squares, all rhombuses are not squares, so on and so forth. So ask you that question, is every rhombus a square? No. Is every square a rhombus? Yes. So that's one thing to think about, but these are your special parallelograms right here. So starting out with properties of rectangles, if we think back to a parallelogram, if a quadrilateral is a rectangle, then it is a parallelogram. Okay, if parallelogram is a rectangle, then its diagonals are congruent. So its diagonals are congruent, and we have 90-degree angles. That's the important thing. Opposite side lengths are congruent to each other, but not all the same. If all four side lengths were the same, then you would either have a square or a rhombus. The nice thing about these problems is it's often just quick addition, subtraction, multiplication, and division with a little bit of algebra. There's no complicated setups, no brand new equations. Moving on from rectangles, we have rhombuses. Rhombus is another special quadrilateral with four congruent sides. Four congruent sides. Notice the tick marks, all four congruent sides. The diagonals are perpendicular to each other. And your, that means here, so 1 and 2 is congruent, 3 and 4 is congruent. So that means your diagonals are also angle bisectors. Very important, angle bisectors to each other. Okay? Talk through a theorem there, and then we have a little bit of algebra. Notice, setting these, it's a rhombus, setting this side equal to this side, solving down and plugging back in. Okay, a little plug and chug when solving for that. We also have some angle measurements here. Okay, again, setting up a little equation you guys know. Since your diagonals are perpendicular to each other, that means 2y plus 10 has to be equal to 90 degrees. Perpendicular is 90 degrees. Allows you to solve for y, which is 40 degrees, and plug back in to find out what your measure of angle WSR is. You can then do the same thing on this one for 2a and for 2b. Squares. Now, squares summarize all rectangles and all rhombuses. Okay, so any characteristic a rectangle has or a rhombus has, a square must have. So we notice a square is a quadrilateral with four right angles and four congruent sides. In this exercise, you'll show that a square is a parallelogram, a rectangle, and a rhombus. So square is all properties of three, just like I stated. First things first, okay, there's 3 steps to verifying a square. You must show your diagonals are congruent. You must show your diagonals are perpendicular. And you must show your diagonals bisect each other, therefore showing the midpoints of the diagonals are the same. So on page 422 in your text, it gives you a walkthrough of how to do all of that. Step 1, show they're congruent, perpendicular, and then they bisect each other by finding the midpoints. Very important. And then there is a proof on page 423. Not going to pay too much attention looking at the questions. Besides in your practice 6-4, a lot of filling in, vocabulary, a little bit of calculations there with 9 and 10, just understanding the different segments. And then there is a proof. Okay, a little bit of proof using theorems that we've used in the past, except for 2a. They do give you a word bank, though, to work with. Just to remember that we still do have proofs in this, it's geometry. So that is it for 6-4, and I will include 6-5 in its own video here coming up next.